In this lecture, I will talk about elastic collision in center of mass frame. So for this, let us understand that what is happening in the center of mass frame before collision. So here there is a particle m1 and this is moving with velocity u1, and there is another particle which is moving with velocity it is u1 prime, and this is the another particle, and this particle is approaching towards this particle, so m2, because when we are looking at this, it seems like this. It is the velocity of center of mass. So when I am trying to look at the particles, both the particles from this center of mass frame, then this particle seems to moving along the center of mass, and or in other words, we can say that both the particles are approaching towards the center of mass and then they will collide, right? So this is the center of mass and its mass is m2, and say it is u2 prime. So that means u1 prime and u2 prime are the velocities when seen from the center of mass. u1 prime and u2 prime are the velocities of these particles, means the velocities of colliding particles when seen from center of mass, right? So as I talked about earlier, that let us assume that in the laboratory frame of reference, let us assume that m1 is moving with velocity u1 in the laboratory frame of reference, and it strike a m2 particle and it is at the rest. Means this is the situation. This is m1, this is the center of mass frame, and this is the situation in the laboratory frame. And m2, it is at the rest, right, in the laboratory frame. And here this is the situation in the center of mass frame. But if I compare u1 and u1 prime and u2 prime and u2, then they are related as I discussed in the previous lecture, that this u1 prime must be equal to u1 minus v. V is the velocity of the center of mass, and u2 prime, it is equal to u2 minus v, and this can be written as u1 minus, and this v can be written as m1 u1. This is also discussed in the earlier lectures. So if I simplify it, it is m1 u1 plus m2 u1 minus m1 u1 divided by m1 plus m2. Similarly, it is 0 minus m1 u1 over m1 plus m2. So it will cancel out with it. So from here I can write down that this u1 prime is equal to it is plus m2 u1 over m1 plus m2. This is one relationship which we are getting. Let me call this as equation number 2, and the value which I have written here, that v is equal to m1 u1 plus m1 plus m2, let me call this as equation number 1, because it is m2 0 and it comes out to be in this case m1 u1 over m1 plus m2, and let me call this as equation number 1. And from here I can write down this u2 prime is equal to minus m1 u1 over m1 plus m2. That's what I am getting. Let me call this as equation number 3. So these equations 2 and 3 suggest that because both the particles are approaching each other, because one having the u1 is sitting with plus sign and here minus u1 is sitting. So this means that equation 2 and 3 shows that two particles move towards each other in center of mass frame, and equation 1, because if we try to look at these two, then both are having the same sign, and equation 1 suggests that center of mass moves in the direction of incident particle. Right, that's what we are getting here. Now what happens to these particles after collision? First of all, let me talk about, say, after collision, one particle starts moving in this direction. Let me call this as v1 prime, and another particle starts moving in this direction. Let us call it as v2. It is the velocity after collision, and say it is the angle of scattering. So how these velocities are related? So because these are the v1 and v2, these are the velocities in laboratory frame after collision. So v1 prime and v2 prime, let me call these as velocities after collision in center of mass frame, and say it is the direction of v. This direction of v means the velocity of center of mass, right? So then this can be written as v1 minus v, and it can be written as v2 minus v. Now, according to law of conservation of linear momentum, m1 u1 plus m2 u2 prime, because I am applying in the center of mass frame this law of conservation of linear momentum. So it is m1 v1 prime plus m2 v2 prime. But as I know that this u1 prime is equal to, it is m2 u1 upon m1 plus m2 plus m2 minus m1 u1 over m1 plus m2 must be equal to m1 v1 prime plus m2 v2 prime. Let me simplify this. This will become m1 m2 u1 upon m1 plus m2 plus m2, here it will become negative, so it is m2 m1 u1 over m1 plus m2 is equal to m1 v1 plus m2 v2 prime, right? So both are equal and opposite, so it will cancel out. So that means the result which I am getting out of it, that m1 v1 prime m2 v2 prime must be equal to 0, which implies that v2 prime is equal to m1 over m2 with negative sign and v1 prime, right? So this is another equation, and let me rename the equations. This is equation number 3 which I am getting. This is equation number 2 and 3, and the equation is this is, let me call this as equation number 4 and this as 5, and this is the equation number 6, and let me call this as equation number 7 and this as equation number 8. So this equation 8 suggests that because v1 and v2 are acting along the opposite direction, because here v2 is the negative of v1, right? So this equation shows that after collision, two particles in center of mass frame moves in opposite direction. They are moving in opposite direction. So that means after collision, say, if I try to look at this diagram looks like this. It is, say, let me call this as v1 prime and let me call this as v2 prime. Now they are acting along opposite directions, right? One along this direction, another along opposite direction. That's what this equation will suggest. And using equation 7 in equation 6, equation 7 in 6, I'm getting that m1 u1 prime plus m2 u2 prime is equal to 0. This implies that u2 prime is equal to minus m1 over m2 u1. So that means if u1 is moving along the direction, then u2 is moving along. This means they are approaching each other. But after collision, they are moving far away from each other, because here is v1 prime, then it is minus v2 prime. v2 prime is along this direction. So that means equation 8 and 9 suggest that particles move towards each other before collision and they move away from each other after collision. In center of mass frame, right? These are the two things which we are getting out of it. And then kinetic energy is also kinetic energy is also conserved, as it is a uniform, elastic collision. So kinetic energy is also conserved. So if I keep this in mind, I can write down that half m1 u1 prime square because here it is a square, so no need to take vector, because vector square convert vector into scalar quantity. So it is half m2 u2 prime square is equal to half m1 v1 prime square plus half m2 v2 prime square. So using, let me call this as equation number 10, and using 8 and 9 in, that is 8 is v2 prime is equal to minus m1 m2 v1 prime, and u2 prime is equal to minus m1 m2 into u1 prime. So as we have to take their square, so that means v2 square is equal to m1 square m2 square v1 prime square, and from here u2 prime square is equal to m1 square m2 square u1 prime square, right? That's what we can use. If I use these values here, then this equation can be written as, it is equal to half m1 u1 prime square plus half m2, here its value will be m1 square over m2 square u1 prime square, right, equal to 1 by 2 m1 v1 prime square plus 1 by 2 m2 m1 square m2 square v1 prime square. So half m1 u1 square can be taken outside, so here it is m1 plus m2, because this m2 will cancel out with it, and similarly this will cancel out with it, is equal to half m1 v1 prime square taken outside plus half m1 upon m2. So now this m1 will cancel out with it, this 1 by 2 will cancel out with it, and this part will also cancel out with it. So that means v1 square, u1 square is equal to v1 prime square, prime is also there, I have missed that, which implies u1 prime is equal to v1 prime. And similarly we can prove that u2 prime is equal to v2 prime. So let me call this as equation number 11 and this as equation number 12. It means that in center of mass frame, the magnitude of velocities of particles remain unaltered after elastic collision. So that means when we look at the system in the center of mass frame, then the velocities of the incoming particle will remains the velocity of the scattered particle and the velocity of the recoiled particle, right? So they will remain the same. Unaltered means they will remain the same. So this is all about this lecture.